my sanity, I am starting this part way through. I'll go ahead and go over how I pulled these up, but you've done it previously already, so I don't want to have to go through this again. I've already messed up this video a couple of times, so this is I think my fourth or fifth time trying to make it. So I want to talk about what you need to have for this assignment for Excel assignment 5 and the corresponding write up. We are going to run an independent samples t-test. So first of all, we look at the scenario. You have 33 college students taking their final statistics exam. You have 16 men, 17 women. Um, I do want to make sure that you understand I want this course to be inclusive, but I just used male and female here because it's a t-test. So we need two groups. This was a quick example, and I just wanted to make sure I stated that in this video for you all. So we have a research question. Is there a difference between the scores for men and women? That's what we want to know. Our null hypothesis is that there is not a difference between the scores between men and women on the statistics exam. And our research hypothesis, though, since we don't have like a specific expectation of one group outscoring the other, I'm going to just say that the research hypothesis would be that there is a difference between the scores. We don't really know which way. We don't have a way we're leaning, so we're just going to say the difference exists and keep that two-tailed hypothesis, okay? Now we have to consider different assumptions. So we have we need to make sure that the dependent variables, which would be this score, the outcome here, is continuous. So we know this is continuous. It's a 0 to 100 scale. You can get an 80.5%. You have um, the ability to have that and it be a valid score. So we're going to call this continuous variable. Um, the observations are independent of one another because there is only one observation per person. Excuse me, I do have a cold. I'm trying to get better, but I'm gonna have moments in this video where I cough or need to clear my throat. So we do have independent observations. This is not a paired samples situation where you have a before and after. This person um, has the one score. Each person has their own score, and these two groups are completely independent of one another. So these observations are independent. As far as outliers, to check outliers, we ran a box plot. So a box plot, we just went to insert and found the box plot under here, right here, and pulled this up. Now, it looks like this is saying there are outliers. The important thing to remember, though, is this really an outlier, or is it possible that um, we just have maybe a small data set, or that it just so happened that the way this worked out, most of the scores were in this small area, but a few were outside of that. So looking at the scores, none of these stand out as huge outliers. However, we have this one, which should be this. Um, you see the values 98 there. This student just did better than the others in their group. That I wouldn't call that an outlier. That's a common thing. Now, if the score was like 1,000 or something like that, maybe it would make sense. Even if it is considered an outlier because of this box plot, do we keep it? I would keep these in. There's no reason to exclude them because this is not. Um, there's nothing here indicating to me that these are going to be a problem. This isn't going to change the mean too much, and if it does, it will change the mean, but it's not going to impact it to a point where it needs to be removed. I wouldn't remove every single outlier that pops up on a box plot. It's just not, thinking about it in context of what is happening, it's not really necessary to remove these. If you do, however, you must report it. Okay, um, and then if that if if that's something that you want to do, go ahead and do that and report it. As far as what I decided to do though is say, there's no problems with outliers and move on. Um, the dependent variable should be approximately normally distributed now in each group. So I ran made histograms based on each of these two columns. You select the data and click insert. You have the histogram here, and that's how I got each of these. Now, these aren't pretty. This one's not as bad, but if you selected this information and then tried to create your own bins off of these, so if I were to do this with 6 bins, it changes it so much visually that my um, my views of these histograms are they do limit. It is limited, especially um, if you're just basing your entire investigation on these histograms. You don't want to do that. So you do need to also pull up the statistics for skew and kurtosis. We're going to just do the descriptive statistics tab, which is under the data analysis. So descriptive statistics, you will have to do each one of these differently separately. Sorry. Um, so you will select the input range, and then as far as the output range goes, you want to say, where do you want this? I want it right here. And I want the summary statistics. I don't need the confidence level summary statistics. And you can click OK, and it'll pop up. You change it to make sure you have it properly labeled. And then you do the same thing. Okay. Okay. Descriptive statistics. Put the proper input range. So I'm wanting the descriptive statistics for females. As far as the output range, I would delete that and just click where you want it. And I want it right by the other ones. I have summary statistics checked. And I click OK. And change that to females. You can also make it men, women, some, as long as you're descriptive in which group it's corresponding to. That's the important part. Okay. Make sure you go to 2 decimal places for any decimal numbers. I would leave the whole numbers as whole numbers. That doesn't matter as much. So looking at the skew and kurtosis, this number is quite high, but it still falls between the -2 and +2 that we want to keep it in. So I wouldn't say it's a problem. However, if you wanted to kind of investigate that, so these are the male scores, the kurtosis is coming from this. So if you click this and you created bins, you can see that's pretty prominent If I made 6 pins, you can see it the most. All the other groups are kind of reduced. But again, and that's something that you don't necessarily see here. So I would just, you do need these histograms to kind of get an idea of how the data are spread out. But these numbers give you a little bit more information to tell you do you have a problem. And I would say no, you don't have a problem with normality. So that assumption has not been violated. Um, Now, as far as the final assumption we have is homogeneity of variance. Basically, are the variances between groups approximately the same? So we can kind of, first of all, observe that. So we have the variance of this group at 105.45 and the variance of this group at 110.81. There is something called a, I'm trying to remember it, but it's a ratio. Basically, you take this number divided by that number, excuse me, and um, if it's less than 4, you're fine. So we know that's going to be less than 4. However, to test this assumption in a better, more complete way, we're going to use it's an F test. So you can click insert, or not insert, I keep going back to that. Click data analysis. Oh, I wanted to mention too, you have problems finding that data analysis tab. Um, I wasn't sure if that was still the case because I have had a lot of people not send me a message about it, but you will need to insert add-ins. You can get add-ins and you can find the data analysis tool pack. That's what I have. I have this written on the front page of our course. It tells you exactly what kind of or what version of Excel I'm using, what analysis tool pack it is, and so I've had that on the front of a course since day one. It's just that we're only now really needing it, so I don't blame you for not seeing that. But it is what I use is on the front page of the course near the bottom, I think. Um, but for this assignment, we're just going to go data analysis. Now we want F test for 2 sample for variances. And I'm going to put the proper ranges in here. Your output range, I'm going to put it here. And then for input ranges, we do the first variable, second variable. Okay. Looks good. Keep your alpha the same. You don't have to change that unless I tell you. And it will pop up. Variable 1, I'm going to go males, females. So I know which group they belong to. I'm going to create the 2 decimal place, or reduce it to 2 decimal places. And as far as the p-values go here, this is just testing if these variances are different. So the p-value here, we've got one tail, 0.46. You can leave it at 2 decimal places because there's obviously there's no significance here. So the this means that there's not a difference. So null hypothesis, there's no difference. The alternative hypothesis, there is a difference. So if this was significant, we would say there's a difference in these variances, and that violates that assumption. But because it's non-significant, it's greater than 0.05, so that's non-significant. So we can say there's not a difference between these two numbers based on the information. These numbers are not significant significantly different from one another. Okay, so that's the goal here. And when we write this out, um, so you do have to mention this in as you are reporting what you did. Um, the F test was used and no violation was found. So as far as F goes, there's two different degrees of freedom here, 15 and 16. Now, I've seen it reported a couple different ways. We could either do the parentheses with 15 comma 16 or this way. Um, I'm lenient on that. So, but preferably, I'm going to be putting that for grading purposes. It would probably be best if you did it this way, because that's just going to be um, how the key is. But as far as this goes, the score was 0.95. That was F. So like I said before, as long as, so 110 divided by the 105 over here, that's going to be 1 point something. Um, it's definitely below 4. This is definitely like low enough. This is about 1, so it about match that. But there is no violation because it's not statistically different. So this is P equals 0.46. Um, that means that I don't have a violation, so I can move on. Um, so at that point, oh, sorry, I have to clear my throat here. At that point, I want to do then my t-test. Okay, so I've already checked all my assumptions, and so I'm going to perform the t-test now. So for the t-test, I'm going to go to data, data analysis, t-test for 2 sample, right? We've got, even though we consider this one big sample, we have subsamples here. We have 2 samples, assuming equal variances. We did have equal variances, so we can assume equal variances here, and that's just fine. And then this is where we change the numbers in to reflect what we needed to test. We wanted to test this group versus this group. And the output range, I want it to be right here. Okay. So I'm going to go and I'm going to change these variable names. I'm going to make sure that we've got 2 decimal places. And now I can use this information for what I need, which is, okay, answers the hypothesis question. We're testing the hypothesis that there's a difference between these 2 groups, right? So that's the hypothesis. That's our research hypothesis. So now we can look at what do we need? First of all, our degrees of freedom is 31 because there's 33 in a group, and normally, or we have to this point, usually subtract 1. However, there's 2 samples, so you need to subtract 1 for each sample that you have here. So we subtract 2, and that gives us 31 for our degrees of freedom. So the T degrees of freedom, 31, is 0.29, or t-stat 0.29. Now the critical value, since we have a two-tail, our critical value to meet was 2.04. So since we only had 0.29, we our p-value is definitely larger than 0.05. So we can say p is greater than 0.05, or we can also say P equals 0.7, which when you, as far as like your italics, you don't italicize the number, you just italicize the symbol, okay? So make sure you're not italicizing your numbers. So because this p-value was larger than our acceptable p-value of 0.05, we failed to reject the null hypothesis that there's no difference between these scores. So we did not find evidence that men and women or women outperformed each other on the statistics exam. So, which that makes sense, right? Um, Based on the information that we have, based on looking at these means, it doesn't, there should not be a difference because these are so close that even if there was a difference, right, even if we had huge samples and we found statistical significance that there was a difference between the two groups, the effect size, if it was the same here, if these numbers were the same, would be substantially lower than um, a large effect or something. You have a small, very small, um, probably smaller, way smaller than the zero point 0.2 that you would normally want for a small effect size. So, but there's no difference, and that's how you would report it. So once we're finished here, we have an an independent samples t-test was conducted to test the hypothesis that there's a difference in the scores between men and women in statistics. Scores between men and women. This is a two-tailed hypothesis. Our outcome variable was continuous, indicating no violation of the assumption. Each group was examined for outliers, and although there were 3 observations that showed up in the male group, the outliers were left because they fell within the normal range of exam score. Distributions of each, oh, I would also put there wasn't a violation for outliers to report. Something like that's fine. It depends on what you want to write here. For me, I would say that this isn't a violation because I do know that if it was larger, it would encompass more information here. So I'd say there's not a violation. If you put that there's a violation, if there's outliers indicating here, I would be fine with it. You just have to have good reasoning here. So, distributions of each variable and skewness and kurtosis statistics were examined to test the assumption of normality. Regarding the scores of men and women, skew and kurtosis were between the -2 and +2, indicating no issues with normality, thus no violation. The variance in the male scores, 105.45, was similar to the variance of female scores, and an F-test was conducted to test this assumption of equal variances, and no violation was found. So, and then I reported the F information, the F statistic here. Scores for men were not different than the scores for women after we ran the t-test because the findings were not statistically significant. Um, Therefore, we failed to reject the null hypothesis, and there was no difference between test scores, indicating we did not find any evidence that men or women outperformed each other on the statistics exam. And for this assignment, that's what you have to do. And also the write-up, same as last week. I hope this was helpful for all of you. And if you have any questions, please let me or course assistant know, and we would gladly assist you. All right, have a good day.